Hello, and thank you for watching my video. This is Mark Moody with the second half of the solution to the Riemann conjecture. I didn't really set out to solve the Riemann conjecture at all. What it does is, I don't know if solving the Riemann conjecture is, it's more like the Riemann conjecture proves my pilot wave correct. I showed you in the first video how my pilot wave, the frequency of my pilot wave, expands and wave collapses out to all the information needed for the Riemann conjecture and much more. This is the actual harmonic zeta function to be used in solving one of the ways to solve the Riemann conjecture. Now, you can see he's got it harmonic here, harmonic series, 1/2, 1/3, 4/5, but that's the other half of the harmonics. Mine goes in 1/2, 2/3, 3/4. So you see 1/4 would be the missing half of my 3/4. But it's the same exact thing, still a harmonic series. I'm just using the other half of it. That's one of Raymond's mistakes, was using this half apparently. Um, and so Raymond knows that we need harmonics to get this done. And he knows that the waves added together, or whatever this harmonic number is, added to this one, should go infinitely basically towards one, but never arrive there. Okay, so he's saying take the reciprocal of these numbers, divide by 1, which is exactly what we're doing. Um, take the reciprocal, and you'll get your frequency, or you'll I'm sorry, you'll get the code that runs out and does exactly what I showed you. Now I'm going to show you it's a real thing. Here is the calculator, 10,000 digit calculator. Got my frequency in there. I put it a little bigger because I want it to expand out a little bit so I can show it to you easily. So I'm just going to divide that by that one, and you'll see there's no trickery. That's a frequency full of information. Boom. There it is, just like I showed you, 9801, 4905 on the last video. Here's the frequency of light, the half of that. So here's, okay, first things we notice are harmonics. Do they add up like his is supposed to? It's 1 plus the next one tending towards 0. This, yes, this plus this 4905 divided by that is 1/2. 882 divided by that is 2/3, 3/4, 4/5, 5/6. So all the way down, we have perfect harmonic series, not just in this row, but in every row. Not just in the columns horizontally, but in or not, but in rows as well. Every one of these rows is 1/2 by 2/3 by 3/4. So all the way across, it's also perfect harmonic series. So this gives us yes, we've definitely got the over 1. We've taken the reciprocal. Okay, that's what's happened here. And it does add up, every one of these, perfectly harmonically, like Raymond suggests. So we see, yeah, that's highly possible. Looks like a match there. And we get him back out here. So it looks like a match there. Um, Now the next thing is the S value. Okay. So what I used here was I used 9 divided by the C squared for the S value. It can be any value you want, as long as it works. So I used 9 because all the numbers add to 9. Every number on this over here, every number in this will add to 9. So horizontally, every one of them, and the harmonic balance is always 9. It always goes up by 9. So we know that 9, as long as you're adding by 9 every time, you're going to get the proper sequence here. It's going to stay harmonic. So it's got to add by 9 to stay harmonic. So I use the 9. I divide that by C squared, which is 279 squared, which is 880, 8820, there it is. 297 squared is 88209. Okay. Now, when I do that, so I do that, and then I plug it into the function. That's my number, which is 10, 20, 30, 40, 50. And I expand it out in the function. Okay, so is 9801. You see that? 9801. So 9 divided by C squared inverted is 9801. So we have two numbers here. We have 9801, and the speed of light squared right there. 3 numbers. Okay. So when we plug those in, those three numbers into the zeta function, what we get for that 9, 6, we get this row of numbers 10, 20, 30, 40. So we get 9801 inverted to this and this number and this number. So this is what you get in harmonic series to the zeta function, which works to solve the zeta function. Here we go. It's the same as my stuff. You're going down, you're going to add up at a point less than 0, never to arrive at the 0, at the point of 1, but they'll all go straight down. Your primes are being made right in the middle again. It works perfectly for, and then I found out why that I did that first, okay, before I decohered the Moody Pilot wave. So we see they got a decoherence in every one of these of 10. Every one of these is perfectly harmonic. Not just the columns are in harmonic order, but every number inside of the columns is in harmonic series, both directions. So it's entangled and it's in harmonic series all the way through. So the 9 and the c squared and the 9801 all work in the zeta function perfectly to bring us to a great solution. And the solution is this one. Look, and you see it. Oh, I could do it right there. Okay. You see it, 9801. And that's the same exact solution. Look, it's the speed of light, 88209, 9801. All of these are increasing by 9 harmonically. So the three numbers that I used in the zeta are the exact same three numbers that come out when I divide the Moody fundamental frequencies of the pilot wave by 1. So all that math of the zeta function, all that stuff they were trying to do, we don't actually need as long as we have the frequency of the zeta function, which is what the Moody Pilot wave frequency is. Because in that frequency, it contains all the information that we need. So, like I said, you cannot argue it. There's no way. You see the prime numbers, how they're being created, coming right down the center, all the trivial zeros. The zeta function works perfectly on it as long as we use the harmonic system. There's nothing left out that this doesn't work involving the Riemann zeta conjuncture. I forgot the name of it. So conjecture. Okay, so actually, there it is. I mean, there's little room for argument there. Um, I've done it two different ways, and they both work and meet every one of the requirements for the zeta function. And that's why it's so cool, because apparently the zeta function is something really cool. I didn't get that, but now I do. It's so important and so really really cool. I don't know how he could have thought of it back then. That's what amazes me, how he described it so perfectly. But I prove him, and he's proving my pilot way to be correct, because one couldn't have happened without the other one. So they're both correct. And stay tuned for more videos, and thank you for watching.